What is up, guys? Welcome to Session 3 of Introduction to Linux System Administration. As always, I'll be your instructor, Kevin Downs. Oops. So today we're going to be going over booting and shutting down Linux. So from our previous session, we went over planning, hardware and software considerations, partitions, logical volume manager, or LVM, file system overview, swap partition considerations, other partition considerations, the Linux bootloader known as grub, software package selection, adding and configuring peripherals such as printers, keyboard, and other things, graphic controllers, basic networking configuration, and booting to recovery mode. Today, we're going to go over the boot sequence, the systemd daemon, this is pronounced as daemon, the systemctl command or system control command, targets versus run levels, modifying a target, service unit scripts, changing system states. We're going to quickly touch on booting into rescue mode again, and then we're going to talk about shutdown commands. So let's get started with the boot sequence. This is important to know because it helps you understand how the Linux machine is actually booting up. And if something occurs during the boot process and you can kind of see where it messed up here in one of these boot sequences, you can kind of troubleshoot a little bit and figure out what went wrong there. So the first thing to start up is the BIOS, B-I-O-S, okay? This stands for Basic Input Output System, and this executes the MBR. MBR stands for Master Boot Record, and this executes grub. And remember, grub stands for Grand Unified Bootloader, and this starts up the kernel. And the kernel executes sbin init, so /sbin/init. Hey guys, if you remember back all the way from our first course, the kernel is what interfaces with the actual hardware on the system and the OS and all that. So once the kernel's up and running and we have /sbin/init started, init executes run level programs. So this is where the system really starts to fire up all its programs and user programs. So from here, run level starts going, and run level programs are executed from /etc/rc.d/rc*.d/. So, a daemon is a service that runs in the background and supervises the system and provides functionality to other processes. Okay, so the daemon is what's really running all the different processes in the background without us having to actually watch over them. Traditionally, daemons are implemented following a scheme originating in sysv Unix. However, in modern daemons follow a simpler yet more powerful scheme. Here they're going to be called new style daemons, and they're implemented by systemd. Systemd is a suite of basic building blocks for a Linux system. It provides a system and service manager that runs as PID1, so process ID 1, and it starts the rest of the system. Systemd provides aggressive parallelization capabilities, uses a socket and dbus activation for starting services, offers on-demand starting of daemons. It keeps track of processes using Linux control groups, maintains mounts and auto-mount points, and implements an elaborate transactional dependency-based service control logic. So systemd is what's controlling all these different daemons, okay? And remember, the daemons are what is controlling all the processes in the background. So systemctl command can be used to introspect and control the state of the systemd system and service manager. So systemctl command is how we're actually telling systemd what to do, how to run those processes, when to start and stop them, status, and other things like that. The fundamental purpose of an init system is to initialize the components that must be started after the Linux kernel is booted, traditionally known as userland components. The init system is also used to manage services and daemons for the server at any point while the system is running. So with that in mind, we'll start with some simple service management operations. The first one being systemd referring to run levels targets. So we can display the new run level targets by issuing the following command. This guy here. So it's going to be ls space dash al space /lib or library /systemd /system /run level star. And guys, remember the star It's going to list everything that begins with all this text in front of it. let's go ahead and open our VirtualBox. I have my terminal up here. Let me log back in. Alright, so I have my terminal here. Hey guys, real quick, actually let me exit out of this just so I can show you something. So on CentOS, we can't right click on our desktop and open the terminal. What we can do is we can just click on that activities and search CMD, which stands for command, and it'll pull the terminal up that way, okay? So I'm going to do an ls space -al space /lib /systemd /system /run level star or asterisk or splat. I'm going to hit enter. You see all these different file systems we have here. Run level 3, run level 4.target, run level 1. Okay. And you'll see all these arrows here. This means this is a symbolic link to another file. So here, this link is being linked to another file called power off target and rescue target, multi-user target, etc. Okay. So let's go back to our PowerPoint. Remember, to get out of your VirtualBox and get your mouse back, you have to hit right on the D-pad and then Control, and that'll free up your mouse. Okay. So that file is where we can see all the different run levels and targets. So let's look at those run levels. So 0 is the power off target, 1 is the rescue target, 2 is the multi-user target, 3 is multi-user target, 4 is also multi-user target, 5 is the graphical target, and 6 is the reboot target. Okay. So how do we modify a target? So while the system is running, you can switch the target, otherwise known as the run level, meaning only one service as well as units defined under the target will now run on the system. So let's look at how to switch to run level 3. Let's run the following command. Remember, run level 3 is going to be multi-user target. So we're going to do systemctl isolate multi-user target. Give me 1 second. Okay, there we go. Let me clear my screen. Alright, so we're going to do systemctl isolate and multi-user, oops, spelled it wrong, multi-user.target. I hit enter. So it's asking me to provide a password to do this. I'm going to go ahead and type in my password. Okay, so we saw we changed the run level target. So now it rebooted to change that target. So now it wants you to log in again, okay? So you're going to type in your login name, which for me was Kate Allen's. There you go. See, now I'm in a multi-user target. So this looks different, guys, right? I lost my desktop and all that, right? So I want that desktop back. I want to boot back into a graphical target. So let's actually go to our PowerPoint real quick. Let's look at that. So to get back to a graphical target, we need to do systemctl isolate graphical.target. So let's go ahead and do that so I can get my beautiful GUI back. So systemctl isolate and graphical.target. Okay. So systemctl space isolate space graphical target. And again, it wants my password. In order to run this as a privileged user, I'll type that in. It's going to reboot. And voila, we have our graphical desktop back. Good as new. Alright, let's head back to our PowerPoint here. So we're actually going to look at how to make our own service unit. Okay, we're going to call it connection.service. Okay, to get to there, first we're going to go to etsy/systemd/system. Okay, let's go ahead and just go there just to see what's there. You open a terminal again. CD, remember CD is change directory, /etsy or etc /systemd/system. Okay, let's go ahead and list everything in there. You see we got all these different programs here. Okay, syslog.service, timers.targets once. We got a lot of different files here for service units. All right, we're gonna make our own. Go back to our PowerPoint real quick. So first we're going to do a vim. We're going to edit and create a file named connection.service. And in that file we're going to do unit, okay, to give it a heading, and then we're going to make the description equal to making network connection up. And then after is going to equal network.target, okay. Then we're going to make another section called service. We're going to do exec start equals root scripts conup.sh, okay. Then we're going to do install wanted by equals multi-user target. Alright. Let's go and go back to our virtual box here. You guys can follow along with me here when we're doing all this. So we're going to do vim connection dot service, and it's going to make this file inside this directory we're in. Okay. You guys remember when we're using vim to type things in, we have to get to insert mode. So I press I. We're going to name it bracket unit. We're going to go to the next line. We're going to do description equals making network connection up. And guys, you notice all these have different colors when we're typing it. So by putting in that heading, the file knows what these following things we type in are going to be assigned to. It's going to be the unit of this script. Okay. After, oops. That's a nice thing about Vim, is it colors it, so it helps you kind of understand what's going on. Okay, we're going to do space, bracket, service, do exec, start, equals, do /root, /scripts, /conup.sh. So this is telling it where to execute from, and install. I'm going to explain all this a little bit more in depth once we actually get this on here. Wanted by, and make sure you guys spell this exactly how it's supposed to be. Remember, everything in Unix or Linux and Unix is case sensitive. So wanted by multi-user target. All right, I'm going to do one quick glance myself to make sure I did spell everything right, and it's all capitalized how it should be. Alright, and then we're gonna save this. So we do escape to get to command mode, colon, right quit. Okay. You guys will see that at the bottom of my screen there. So right quit. Okay. Enter. Can't open file for writing. Oh. Right quit. Okay, let's try right quit exclamation point. Interesting. Oh, I think I know why. Okay. I think I need to do this as a privileged user. Interesting. Okay. So this brings up an interesting point. So I was going to switch to a privileged user on there. You can see where I tried to do sudo. And it tells me that I'm actually not in the sudoers file. Okay? That's something I'll have to add later on, but for right now, what we're going to do is we're just going to go ahead and switch to root. So if you guys remember how to do that from our last course, let me clear my screen real quick. We're just going to do su dash. And that's going to switch me to root. Now I'm root. Okay, let's try that again. Let's go to cd/etc/systemd/system. Yep, we're in the right one, so we're going to do vim. And it's going to be /etc, or sorry, connection dot service. And we're going to type all that in again, so unit. And description equals making network connection up, and oops, after equals network dot target service, exec start equals /root/scripts /con up.sh. Con up means connection up. Install. Oops. There we go. And wanted by equals multi dash user dot target. Alright, this should fix the problem of it not wanting to save the file. So escape, right quit. Sure enough, yep, it just wanted me to be a privileged user in order to write that file, okay? Let's go back to our PowerPoint. So we typed all in, we made that file. Let's explain a little bit what we did. So to explain what we did just above, we have created a unit of service type. You can also create unit of target types. And we have set it to be loaded after the network.target. Okay, you can understand that booting procedure reaches the target with a defined order. We want every time the service start to execute a bash script with the name conup.sh, which we are going to create. And I don't think we actually will create this, guys. I just wanted to kind of show you how you can create a service unit on your own. So the fun starts with the last part, which is the install part we saw. It tells that it will be wanted by the multi-user target. So if we enable our service, a symbolic link to that service will be created inside the multi-user.target.wants folder. So we're going to go ahead and try and enable it. We're going to do that by doing systemctl enable connection.service. Okay, let's go ahead and try it. See what happens. So systemctl enable and connection.service is what we named our file. Perfect. Yep. And you see there it says created symbolic link etc systemd system multi-user target.wants connection.service to etc systemd system connection.service. Okay. You guys see that there? It created that system or symbolic link. Okay. So let's go ahead and list the multi-user targets.wants folder just to see it under there to prove to you that that link was created. Okay. I'm going to clear my screen real quick. So I'm going to do ls multi user target wants / let's see what's under there. And actually, let's use another trick we learned. I'm going to call it connection. You guys remember grep is going to find everything in there that has the word grep in it. That way I don't have to try and find this by my eye. So we see there connection.service is listed underneath this, so a symbolic link was created. Let's do another thing here. See if I can see it. Well, okay, so it's not listing it in here. That's okay. No need to worry about that then. Let's go back to our PowerPoint. So a Linux system may run in one of 7 possible states numbered from 0 to 6, as well as the single user state that letters S or capital S represent. So here's a description of those states. State 0 is the halt state, so when you switch a system to state 0, it will shut down immediately. State 1, known as the administrative state, allows access only to a super user. Using this state, a system administrator can perform various maintenance operations and installations without interference from others. State 2 is the partial multi-user state. It allows multiple users to log in, but it disables remote file sharing. So state 3 is multi-user state as well. It allows multiple users to log in and enables remote file sharing. This is the default state for the command line interface. And we saw that earlier when I switched to 3. State 4 is unused. State 5 is the default state for graphical logins that use display managers such as GDM and XDM. If you choose to use graphical logins during the installation process, this will be your default state instead of 3, which would be the default otherwise. State 6 shuts down the system and reboots it. So note that when we did state 0, it only shuts it down. It's not going to reboot it. So state S, or capital S, is a single user state and restricts the number of logged in users to 1. So let's check that out. So if we want to change states, we can use the init command. So for example, we can do init lowercase s. That'll change single user state, or we can do init 0. Let me show you that real quick. We're going to change it to init s. Actually, real quick, let's do a run level command. Just see what run level we're currently at. We'll hit enter. And we're at run level 5. Okay? Which is, of course, the graphical one. We're going to do init lowercase s. It's going to reboot, take us to single user state. It's telling us to give the root password. Storing that single user state, which of course is going to be the command line interface as well as the rescue mode. So we're going to do init 5 to get back to our graphical state. And there we go, we're back at our graphical interface. Let's go back to our PowerPoint. So RescueMu provides the ability to boot a small Red Hat Enterprise Linux environment entirely from CD-ROM or some other boot method instead of the system's hard drive. So as the name implies, rescue mode is provided to rescue you from something that happened. During normal operation, your Red Hat Enterprise Linux system uses files located on your system's hard drive to do everything. Run programs, store your files, and more. However, there may be times when you're unable to get Red Hat Enterprise Linux running completely enough to access files on your system's hard drive. This happens a lot when you mess with the /etc/fs tab guys, which is where you mount all your drives. So using rescue mode, you can access the files stored on your system's hard drive, even if you cannot actually run Red Hat Enterprise Linux from that hard drive. So it's a good way to get in there and do some maintenance when your system's kind of locked up. So to boot in a rescue mode, you must be able to boot the system using one of the following methods. So either by booting from CD-ROM, another boot device or media such as USB flash drive, or by booting the system from Red Hat Enterprise Linux CD-ROM number 1. So guys, once you have booted using one of the described methods above, you can enter the keyword rescue as a kernel parameter. For example, for a 86 system, so by 86 architecture, type the following command in the installation boot prompt, Linux rescue, and it'll put you in that rescue mode. To shut down your system for a terminal session, you can sign in, switch to root or SU, and then you can type in /sbin/shutdown-h now. It's going to take a couple moments, but this is going to terminate all processes and it's going to shut down your system. I can show you that real quick. Since we're at the end of our session here, let's go ahead and shut our machine down. Let's log in twice, I guess. Log in. Oh, weird. Alright. Interesting. Looks like our machine did something weird. Let's try this. Huh. Alright, give me 1 second, guys. I don't know what's going on with my VirtualBox here, but it's kind of locked up. I'm going to power it down a different way. Alright, well that's firing back up, so I can show you guys how to shut it down on the terminal. Let's talk about what we learned. So today we went over the boot sequence, the systemd daemon, system control command, targets versus run levels, modifying a target, service unit scripts, changing system states, booting into rescue mode, and shutdown commands. Next session, we're going to go over identifying software packages, using RPM to manage software, using yum to manage software, installing and removing software, identifying devices, displaying device and system info such as PCI and USB, plug-and-play devices, and device configuration tools. Let's see if our VirtualBox is booted up here again. Weird. Okay, give me 1 second, guys. There we go. Okay. Let's see if it'll let me in here. If not, I'm going to have to do some troubleshooting of my own, figure out why it won't let me log in. There we go. Not sure what was going on before, but nothing the old on-off trick can't fix. So to actually shut down our machine from the terminal, we do /sbin/shutdown -h now. That'll shut down the machine from your terminal. Give it some time, and then it shuts down. Alright, let's go ahead and conclude today's session. So thanks for joining me, guys. As always, if you need a little bit of extra help, go ahead and follow these links for some private tutoring sessions. We have weekly and monthly plans, and if you want some additional help, we have one-on-one sessions. And we can do that for Linux and Bash scripting. Thanks so much for joining me, guys. Looking forward to seeing you in our next session.